Welcome to the homework help for Module 9.1. We are on the bottom, or not on the bottom of the page, but we are on page 432. We are starting with number 3. The instructions are write the given expression as an equivalent rational expression that has the given denominator. So it wants you to rewrite this thing with this as the denominator. Basically, it's asking what's the numerator going to be. So that's the question. Pause and try it for yourself. So for this, we have to look at what we have, look at what we're supposed to have, and say, well, how do I change x plus 8 into x cubed plus 8x squared. And so I want you to notice there's no additional terms, so we can't be multiplying by binomial. Like if we multiplied by, for instance, x plus 1, we would have a plus 8 tacked onto there. So there's no way that this could be multiplied by a binomial. It must be multiplied by a single factor, a monomial, in other words. So in order to change x into x cubed, we must be multiplying by x squared. And so I think that's going to be the key for this one. We need to multiply the numerator and the denominator by x squared. Let's just double check, make sure it works for the second term. 8 times x squared is, what do you know, 8x squared. And so all we have to do is multiply the numerator by that same thing, and we will get our answer. And that is what we're looking for. So that's the same denominator they asked for, and that we have found the correct numerator to go along with it. All right, great. So that is number 3. Let's go ahead and pause and try number 4. Number 4 is an interesting problem. One of the interesting things about it is that the denominator looks absolutely nothing like the denominator that we currently have. So let's factor this a little bit, and let's see if we can make heads or tails of what they're asking. Okay, so we have 3 times x minus 2 on our denominator now, and what they want is 2 minus x times x squared plus 9. So this is actually something I'm surprised that this is the first time that, at least that I've noticed, that I've seen this in the Algebra 2 book, because this is a very common and kind of famous trick. If you have x minus 2 and you want to change it into 2 minus x, all you have to do is multiply by a negative. And so here's how that works. If you have x minus 2 and you multiply by negative 1, in fact, we'll just cancel these 3's for now, and then I'll show you what I mean. If I was to multiply the numerator and the denominator by negative 1, it would turn into this. Okay, cool. So why on earth would I do that? Well, because this changes it into negative x and positive 2, which is exactly what we have right here. And so this is I guess it makes sense. We haven't been working with fractions that much, so I guess it's not surprising. This is the first time that we've seen this little trick, but that's how it works. Multiplying by a negative will change the x minus 2 into 2 minus x. And so we're halfway there. We have the 2 minus x on our denominator. Now, well, if we have 2 minus x, all we have to do is multiply by x squared plus 9, because that's what's supposed to be on the denominator. So let's go ahead and rewrite this. All right, there we are. Let's go ahead and actually multiply everything out. Our denominator we can leave unexpanded because that's the way they gave it to us. And our numerator, we're just going to multiply that x cubed times our 2 terms on the numerator of the other fraction. Don't forget the negative. And there we are. So that's a tricky one. Very interesting problem. But that's what I got for my answer. Hopefully you got something similar. Well, hopefully you got the same thing, didn't you? So let's move on. Number 5, simplify the given expressions. All right, so I'm going to go ahead and factor these. Let's see what we get. So we get, so I'm going to take out the negative 4 from the numerator. And I actually get 1 plus x. I'm just going to switch that around and call it x plus 1. That's going to be the more common way of seeing it. Again, that's kind of the same trick for number 4. If you take out a negative, you can switch around. If you take out, or if you add in a negative into a binomial like that, you can kind of switch around where the x goes, where the minuses go. Of course, they were both minus in this one, so whatever. Let's factor our denominator, and I get x plus 1 over x minus 2, and we can cancel. All right, so remember that since we did cancel, we have an excluded value. Having a 0 on both the numerator and the denominator causes a removable discontinuity, but we have to state what that excluded value is. So this is exactly the same equation, or rather expression, I should say, as long as you don't plug in -1, because if you do, well, then you have 0 on the numerator and the denominator, and that can't happen. So that's the answer that I got for number 5. Go ahead and pause and try number 6. One more time, I'm going to factor these. That's what I get, and I also see some canceling opportunities. Once it's canceled, I'm left with -1 on the numerator and x plus 1 on the denominator. I did cancel that x plus 8, which leaves me an excluded value of -8. So that's 3 through 6. Let's go ahead and move on. All right, we're moving on to 9 and 10. 7 and 8 is just more practice of an older topic, so let's move on to the newer topic. This is what we've talked about in class most recently. So we want to find the lowest common denominator for each set of rational expressions. All right, well, let's start off by factoring each one and see what we have in each fraction, in each denominator, and what's missing in each denominator. All right, so we are looking at the denominators of each fraction, and they actually have absolutely nothing in common. And so this is like if you were trying to add 1/2 and 1/3, those denominators have no factors in common, and so you would have to just multiply the denominators together. We're going to have to do the exact same thing. Notice it only says find the lowest common denominator, so we can actually completely ignore the numerators at this point, because all we're looking for is the denominators, and since they have absolutely nothing in common, we have to just multiply the denominators together. That will find us the lowest common denominator. So that's what I got when I filled in my table. I used that calculator just to be sure. I didn't know 16 times 27 off the top of my head, sorry. So we can combine everything, add everything back together, combine like terms, that's the word I'm looking for. And our lowest common denominator is going to equal, all right, that is our lowest common denominator. If we were like adding or subtracting these, we would have to see if there's any common factors in the numerator and the denominator once we've fully combined them, but we don't have to do that. It's just the LCD for this problem, so we're done. Let's go ahead and pause and try number 10. All right, once again, let's factor. Normally we would factor the numerator and the denominator, and if you did, my hat's off to you, but we don't have to because it's only asking for the lowest common denominator. We do not care about the numerator. So in fact, I'm even going to leave off the numerator when I factor this. Okay, this time when we factor our denominators, we can see that they actually do have something in common. They have an x minus 6. So I don't have to multiply the denominators together. In fact, doing so, it wouldn't get me a wrong denominator, but it would get me one that's more complicated than it needs to be. So this is kind of like trying to add 1/4 and 1/6. You could multiply those denominators and get 24 as your denominator. However, that's not the lowest common denominator between a fourth and a sixth. Actually, the lowest common denominator would be a 12 because they both go into 12. And so since these denominators both share x minus 6 in common, we don't need to multiply x minus 6 towards the other side. We just have to multiply this one by 7 and this one by 5, and we get our lowest common denominator, which is going to be 35 times x minus 6. If we wanted to, we could, distribute that back out. And I think I did that math correctly. I think it's minus 210. So these would both be acceptable for the lowest common denominator. And that's number 10. So let's move on. We are skipping on to numbers 15 and 16. This is the main course. We want to actually start adding and subtracting these rational expressions. So let's go ahead and give it a shot. Pause and try number 15. All right, so on number 15, there's nothing to factor. It's already factored, but we do still need to find the lowest common denominator for our two fractions and then actually add them together. I'm going to rewrite this one as x plus 1, just because I'm picky and I like having x first. I like it to be in standard notation. And that's not necessary at all, but I like to do that. I'm going to multiply this left denominator, not just denominator, this left fraction by x over x. That's the denominator of the other one. I'm going to multiply this one by x plus 1. All right, let's do those multiplications. After this step, let's actually multiply these out. All right, I'm just checking my work. I do believe that is negative x squared plus 1. I rewrote that as negative x plus 1. And that should be negative x times 1 and x times 1 cancel. Yeah, that looks good. Now that we're this far, let's go ahead and combine these. Okay, our next goal should be to factor. And this is going to be an interesting one. Those two fractions do combine to get us this one. And looking at this problem, it does not appear to be factorable. You could do some funny business like take out a negative 1 and have things like x squared minus 1, but you'd have this extra plus x in here. So I'm going to go ahead and say that this is, as a whole, unfactorable. There's some things that you could do to mess with it, but I'm going to go ahead and leave it like that. It does not appear that the numerator is factorable, so therefore we're done there. If it's not factorable, then there's nothing to cancel. All right, so that's number 15. Let's go ahead and pause and try number 16. Okay, so for number 16, well, this is an interesting problem because it already gives us a like denominators. So all we got to do is add them together. So that's a little strange that they would be so nice, but we're not going to complain. So let's go ahead and add our numerators. Okay, and it appears as if we can cancel the x plus 2's, right? But you actually can't. That's because it's negative x plus 2, so you have to take out that negative, and this will actually change into negative times x minus 2. So actually it's the x minus 2's that will cancel. I'll prove it. Okay, now it should be more visible that these are the things that cancel. And if that's true, then we are left with negative 1 over x plus 2, as long as you do not plug in 2. So that is our answer for number 16. Let's continue. Number 17. Go ahead and pause and try it for yourself. All right, on number 17, again, I don't know why they keep doing this. 2 plus x, I'm going to rewrite that as x plus 2. And they have also 2 minus x. I'm just going to go ahead and rewrite that because it was annoying to me in the last problem that it was written like this. I'm going to call that negative x plus 2. That's just how I expect to see my expressions written, so that's how I'm going to write them. Okay, cool. So this time we are subtracting. There's a number of ways we could do this. And here's the way that I'm going to do this. If it's not exactly the same, that's okay, but we should arrive at the same answer. I have an x plus 2. I want to multiply that by x so that the denominators match. And then x, I'm going to multiply by x plus 2. All right, there we are. Let's multiply out our multiplications, our fractions. All right, very good. And finally, let's combine everything. So this time, remember that we are subtracting. So we're going to subtract negative x squared. So it's going to actually turn into positive x squared. Same thing with that positive 4 is going to change into negative 4. Okay, let's check to see if this is factorable. And it's not looking like it to me. Once again, we have a numerator that does not appear to be factorable. And if the numerator is not factorable, then there's nothing to cancel on the denominator. I do believe that's the best we can do. So that would be my answer. And I would say, all right, done. Let's move on to number 18. Go ahead and pause and try it for yourself. So for this one, we have once again the same denominator. This book is giving us very strange problems. I apologize. But whatever, they're problems that we can work on. So if they have the same denominator, then we can just do the subtraction. And there we are, 4x to the 4th minus 4 over x squared plus 1. Let's factor our numerator, because it actually can be factored. And it might look like we're at a dead end, but actually it can be factored one more step. X squared times x squared is x to the 4th, and then of course 1 times 1 is 1. So we could actually use difference of squares here, even though that's not a square. It's a square of x squared. So it's kind of strange, but it will look like this. There we go, that's the correct answer, and we can now cancel. So once it's canceled, we do have to state the excluded value, but we don't even have a fraction anymore. It's just going to be 4x squared minus 4, just so long as x does not equal. Ooh, this one's an interesting one, actually, because it's x squared plus 1. When does that equal 0? Never. I'll prove it. So there is a time, okay, I guess I lied. There is a time where x squared can equal negative 1, but only if x is positive or negative I. And they make their triumphant return in an unexpected place. So x cannot equal plus or minus I. And hey, they never told us to take into account whether or not we are taking into account only real numbers or complex or whatever. And so we do have to include it. If they say, hey, we're only working with the reals, then we would not have to include this because I would not be included anyways. But, as long as it's not specific about what type of numbers we're using, we should say, hey, don't plug in I, otherwise these are the same expression. Okay, so that's number 18. Very strange and interesting problems, I'll say, that they're giving to us. Let's move on to our final 2 problems. We are on to number 19. Go ahead and pause and try it for yourself. of course, I'm going to start by factoring this. It looks like x to the fourth minus 2 cannot be factored. If it was x to the fourth minus 1, it could be factored as a difference of squares. But minus 2, I don't think so. Not unless we used like a square root. But let's not do that. So let's leave this unfactored. Our denominator, this one also cannot be factored. Well, that's annoying. You know what? None of it can be factored. Nothing can be factored, so I'm going to stop doing that. But here's something that we can do. Well, x squared minus 2, that's the same as negative x squared plus 2 if we were to multiply it by negative 1. And so all I'm going to do is I'm going to take, in fact, get 19, get out of here. Actually, you know what? I'm going to do it to the other side, so that way I have a positive x squared rather than negative. I'm going to multiply this by negative 1 over negative 1 because the negative 1 times negative x squared will give us positive x squared. Negative 1 times positive 2 will give us negative 2. So that one's definitely interesting. It's continuing the trend on interesting and strange problems that we're working with, but that's okay. Helping us think outside the box a little bit. Okay, so our first fraction will not change, but our second one, all of the signs will be flipped, inverted. All right, cool. Let's go ahead and add those together. And the only thing we're adding is negative 2 plus negative 2. Fair enough. Now we actually can difference of squares our numerator. And we see the same factor in the numerator and the denominator, so our final answer is going to be this equation simplifies to x squared plus 2, so long as you do not plug in, let's see which number. So x squared minus 2, so the 0 for that would be positive or negative square root of 2, because that's the solution for x squared equals 2. So that is, again, another interesting problem. Not really what I was expecting from this homework assignment, but that's okay. We are on to our final problem. This one almost, dare I say it, it kind of looks like it's set up like a normal problem. So let's give it a shot. We're going to start. Oh, I'm sorry, you're going to start by pausing and trying it for yourself. So we are going to start now by factoring. All right, that's what I get when I factor, and finally we get a problem that's, well, more normal from what these types of problems usually are. So I'm looking at the denominators, seeing what each denominator has. This one's x plus 4 and x minus 1. This one's x minus 1 and x minus 2. So they both have an x minus 1. I do not need to multiply their denominators together. I just have to multiply what's missing. So the left denominator does not have an x minus 2, so that's what I'm going to multiply both sides by. On both sides, by both sides, I mean numerator and denominator. The other one is missing an x plus 4. It doesn't have it, so let's put it there. All right, we're going to leave it in factored form when we do this, just because some things might cancel when we finish anyways, so let's see what happens. All right, that's what I get, and some things are definitely not going to cancel because when I do the subtraction, x minus x is 0, negative 2 minus 4 is negative 6, so my final answer is if it was asked to put it in expanded form, so not in factored form, I could, box method out x plus 4, x minus 2, and then box method that result times x minus 1 to get the final expanded version. But it didn't ask me to do that, so I'm not going to do it. So there we go. That is my final answer. Since I didn't cancel anything, there's no excluded values. And thank you for watching. Hope that was helpful. And good luck on it, and I'll see you next time.